Hello, good day! Ito nga pala ang inyong Sir Jello at mayroon ako ulit ituturo sa inyo na math video topics. Pero bago yan, huwag niyo munang kalimutang mag-subscribe sa aking YouTube channel na Sir Jello para maging updated kayo sa lahat ng videos na i-upload ko. Hello, good day! So, welcome for another edition of math video tutorials. For this week, we're going to discuss about proving similar triangles. Similarity theorems. Theorems about similarity between triangles. So there are actually three theorems. We have the AA Similarity Theorem, the SAS Similarity Theorem, and the SSS Similarity Theorem. Let us first have the definitions of postulates. So when we say postulates, these are statements that is accepted without proof. And theorems, these are truth established by means of accepted truths. So these are the terms that we're going to encounter in geometry that we have to understand for us to apply these in proving similar triangles. These are also used to simplify the writing of proofs to prove similarity between triangles. But let us have first the AAA Similarity Postulate. So it is read as if the three angles of one triangle are congruent to the three angles of another triangle, then the two triangles are similar. A good example of this postulate is the equiangular triangle, which has all angles congruent. Let us consider this triangle. We have triangle ABC and triangle DEF. So, of course, we know that it has three corresponding angles. We're going to write all of them. So yung angle A corresponds to angle B, angle B corresponds to angle E, then angle C corresponds to angle F. Once you have the corresponding angles, you can now say that angle A is congruent to angle B, angle B is congruent to angle E, angle C is congruent to angle F. Since you already have three A's here, so you have the first, second, and third A's, we can now say that triangle ABC is similar to triangle DEF. Next, we have the AA Similarity Theorem. So if two angles of one triangle are congruent to the two angles of another triangle, then the two triangles are similar. So here we're going to list down the statements for us to justify this theorem. So say you have triangle ABC and triangle DEF. So you can see here you have two arcs showing the congruency of these two triangles. So you have angle A corresponds to D, then angle C corresponds to angle F. So if these two A's in the AA Similarity Theorem are congruent, let us prove if triangle ABC is similar to triangle DEF by writing the two-column proof, which is statements and reasons. So the first statement here is the given statement, of course. So this is the first A, this is the second A. Angle A is congruent to angle B, angle C is congruent to angle F, so always the reason is given. Since these two A's are congruent, you can say that the measure of these two pairs of angles are congruent by the definition of congruent angles. And then we can add that the measure of angle A plus the measure of angle B is equal to the measure of angle D plus the measure of angle E. B and E here are the third angle that we're going to prove that they are congruent. So the reason for number 3 is addition. So we actually add the third angle by addition property of equality. So number 4, the measure of angles ABC is equal to 180 degrees. The measure of angles D, E, and F is also 180 degrees. And of course, this is true for any triangle. The sum of the measures of the three angles in a triangle is equal to 180 degrees. And then number 5, we can actually say that the triangle or the measure of angles ABC is equal to the measure of angles D, E, and F using the transitive property of equality. So we are, of course, have the prior knowledge of the different properties of equality for us to justify our reasons. Then we can now take the measure of angle B is equal to the measure of angle E by subtraction property, removing the other two angles. For number 7, the angle B is congruent to angle E by the definition of congruent angles. This is actually our third A. So we can say that triangle ABC is similar to triangle DEF by the AAA Similarity Theorem. So you will notice that we change from postulate to theorem because we gathered all the evidences or statements that includes 3 A's. That's why we can state for the reason that this is the AAA Similarity Theorem. Okay. Next, we have the SAS Similarity Theorem. If two sides of one triangle are proportional to the corresponding two sides of another triangle, and the respective included angles are congruent, then the triangles are similar. So from the acronym SAS, side, A here stands for the included angle, and then another S. Now let's have the first triangle. So we have triangle ABC and triangle DEF. So of course we know that this side AB corresponds to side DE, side AC corresponds to side DF, and this is their included angle, angles A and B. So if you're going to write it by proportion, the given is AB is to DE equals AC is to DF. And the included angle is angle A is congruent to angle B. So this is our first S, this is our included angle, and this is the second S. So then, we can say that triangle ABC is similar to triangle DEF. So let's have the example here with given measurements. So let's say you have triangle LOV and triangle CRY facing each other. So we have The first S, which is LV, corresponds to CY. Side OV corresponds to side RY. And then you have the included angle Q. Angle B and angle B. So obviously we can use the SAS Similarity Theorem. So the information that we have, LV over CY, that's 8 over 12. OV and RY is equal to 10 over 15. So the two pairs of corresponding sides are proportional. The measure of angle B is congruent to measure of angle Y with 30 degrees. The included angles are congruent. Therefore, triangle LOB is similar to triangle CRY by the SAS Similarity Theorem. Last is the SSS Similarity Theorem. If the sides of one triangle are proportional to the corresponding sides of a second triangle, then the triangles are similar. So we have here triangle PQR, triangle XYZ. So with the SSS Similarity Theorem, so that means all sides are proportional to the corresponding sides of another triangle. So it's just like in the conditions for similar triangles that the corresponding sides must be proportional. So if we're going to write down the corresponding sides that are proportional, so we have PQ corresponds to XY, QR corresponds to YZ, and side PR corresponds to side XZ. Since these sides are proportional, then we can say that triangle PQR is similar to triangle XYZ. Thank you for watching. I hope you understand the lesson about similar triangles and its theorems. With that, have a good day.